My name is Felicia Orth, hearing officer appointed by the Environmental Improvement Board to conduct a hearing in EIB 21-27. We have 3 public comment sessions a day, including one at 1 o'clock. We've reached the 1 o'clock session. Public comment is taken under oath, is taken by audio, not video, and is limited to 5 minutes. Several folks reached out to the board administrator, Pamela Jones, to request a spot this afternoon. I'll call you in the order in which you reached out. Glenn Schiffbauer, Patricia Stern, Luis Guerrero, Marla Painter, John Jones, and Anna Rondon. In the event you're on the platform to offer comment, and I did not just read your name, please reach out through the chat, which is enabled for everyone, and I'd be happy to take your comment. There are 10 more public comment sessions this week at 9, 1, and 5 each day between now and Friday. So let me look for Mr. Schiffbauer. Mr. Schiffbauer, I'm unmuting you. Can you hear me?
Yes, I can. Thank you.
Oh, your voice is coming through nice and clear. Would you please spell your name?
Yes, first name is Glenn with 2 N's, Glenn. My last name, Schiffbauer, is Schiffbauer.
Thank you. If you would raise your right hand, do you swear or affirm to tell the truth?
I do.
Thank you. I'm going to start your 5 minutes now.
Thank you. Good afternoon. My name is Glenn Schiffbauer, and I'm the Executive Director for the Santa Fe Green Chamber of Commerce here in Santa Fe. I want to thank the EIB for this opportunity to speak. The Santa Fe Green Chamber has been involved with the methane mitigation issues since 2014, and I would like to speak a little bit about job creation today. New research shows that reducing methane emissions from oil and gas facilities not only helps clean the air, as we've been hearing the past few days, but it is a creator of good, high-quality jobs also. Over 200 companies across the country are helping to manufacture the technology and provide the services needed to reduce harmful oil and gas pollution. These industry jobs offer well-paying employment opportunities across the country that can't be offshored, saving money, minimizing waste, and keeping otherwise lost product in the pipe while reducing harmful pollution. Some key facts. There are over 225 manufacturing and service companies with nearly 1,000 employee locations across the country. The methane mitigation service sector in the U.S. has nearly doubled in size since 2017. 65% of these are small businesses, like most of our businesses in New Mexico, and they have the potential to grow larger with the expansion of national methane reduction efforts. 3/4 of manufacturing firms and 88% of service firms report that they could create more jobs as national methane standards are tightened. The starting salary for methane mitigation jobs is nearly 10% higher than the national average salary. We have 11 locations in New Mexico where methane mitigation companies are operating, and we have 5 company headquarters here: Lassen, Sky, Mesa Photonics, Engineered Concepts, and Spectral Sensor Solutions all have homes here in our state. And on another note, there has been some industry concern regarding the impact that these rules might have on smaller producers. While the Santa Fe Green Chamber of Commerce is an advocate for small business, we expect all of our member businesses to abide by the laws and the regulations of their industry. A small restaurant has to pass health inspections just as a large one does. If keeping your restaurant clean and healthy isn't something you can afford, you perhaps maybe have the wrong business model and should think about other ways that you can make money. The same should apply in this industry. Governor Lujan Grisham has committed to putting us in the position of being a national leader with these proposed rules. Let's be a national leader in methane mitigation job creation as well. I thank you for giving me the time today.
Thank you very much, Mr. Schiffbauer. I'm going to look for Patricia Stern next. Let's see here. Um, all right, I'm not seeing Ms. Stern. Let me see if I have any call-in users. Call-in user number 10, would you speak up? Who's this? Hello? I'll go back to call-in user number 10. So I don't see Ms. Stern. Let me turn to Mr. Guerrero. Here you are. Mr. Guerrero, I've unmuted you. Can you hear me?
Yes, can you hear me?
Yes, thank you. If you would please spell your name.
Of course. It's Luis, Luis, last name Guerrero, Guerrero.
Thank you, and raise your right hand. Do you swear or affirm to tell the truth?
Yes.
Thank you. I'm going to start your 5 minutes now.
Okay, thank you. And thank you very much, everyone, for the opportunity to provide a comment this afternoon. My name is Luis Guerrero. I live in Las Cruces in Doña Ana County. For work, I am the legislative and political organizer with the Sierra Club Rio Grande chapter, but I am representing and speaking for myself today. I am today in favor of strong precursor ozone rules, and here are some reasons why. Oil and gas pollution have been taking a toll on all New Mexicans, our air, our water, and our health. Rural communities, tribal communities, children, and also the elderly are especially at risk. In fact, the American Lung Association gave New Mexico's top oil and gas producing counties, Lee, Eddy, and San Juan counties, an F grade for ozone in the 2021 State of the Air report. Oil and gas operations are a significant source of ozone forming VOCs from venting, flaring, and leaks, well site toxins that can worsen respiratory diseases and trigger asthma attacks. Smog can also worsen emphysema and impact the cardiovascular system. Having worked in various areas in southern eastern New Mexico, I can tell you that this is true and it affects people in so many ways. It can include, as I mentioned, respiratory issues, asthma in kids, and can result in also missed days at school and work for parents, which ultimately affects the economy or local economy and people being able to provide for their families. We are living right now in historically dangerous times. New Mexicans are already experiencing severe impacts of climate change that is in part powered by methane that pollutes out of oil and gas operations with ozone precursors, harming our health, our air, land, water, and our economy. Scientists, NASA, and the Department of Defense all agree that climate change is a threat to our kids' future, and we can no longer ignore the increasingly severe weather. Reducing methane, waste pollution, and which is associated benefit of these rules is a key step for Governor Lujan Grisham's strategy to address air pollution and climate impacts caused by oil and gas facilities. And the governor has committed to enacting nation-leading methane emission rules. We need to do better for the future of New Mexicans and our planet. Again, I am in support of strong precursor ozone rules. This would not only prevent potential health risks, but also be beneficial to our planet. We only have one planet. We do not have a planet B. New Mexico can and I believe will be a leader when it comes to fighting climate change and make a difference for future generations. Thank you.
Thank you very much, Mr. Guerrero. We turn now to Marla Painter. Ms. Painter, can you hear me?
Yes, can you hear me?
Yes, I can. If you would please spell your name.
Yes, Marla, Marla, Painter, Painter.
Thank you very much. And if you would raise your right hand, do you swear or affirm to tell the truth?
I do.
Thank you. I'll start your 5 minutes now.
Thank you. My name is Marla Painter, and I live in the Mountain View neighborhood of the South Valley. I'm representing Mountain View Community Action, a grassroots group working to improve the environment, health, and well-being of the residents of Mountain View and the bosque next to our homes and farms. I want to thank you for allowing me to speak before the EIB on strengthening the rules that regulate the precursors to ozone. I bring to the discussion a perspective that does not come from a scientist or an industrial voice or one even of the communities directly impacted by oil and gas extraction. I come from a community that suffers from unhealthy exposure to locally generated VOCs and the broader exposure to ozone. Mountain View is a neighborhood primarily Hispanic Chicano that has existed for over 100 years. 40 years ago, Bernalillo County decided to zone a swath of vacant land in Mountain View, formerly subsistence farms, for industrial use. As a result, we live next to oil and gas terminals, oil and gas transloading facilities, asphalt plants, salvage yards that dismantle vehicles and degrease and clean vehicle parts, salvage yards that accept barrels of unidentified toxic materials, idling train engines, vehicle body stripping and repainting facilities, contractor yards that store the chemicals used for stripping and repainting road lines, dumping yards for old asphalt, facilities that house chemicals, the identity of which the Homeland Security Act cannot allow us to know. The monitoring of these facilities is thin and inadequate, especially in an airshed like Bernalillo County, which is at levels of ozone that impact the health of many people who live here. Bernalillo County cannot adequately monitor these VOCs with their current policies. The city of Albuquerque does not monitor many VOCs, and there is no fence line monitoring. Yet the residents of Mountain View, like many residents of communities next to oil and gas, wake up to the pungent odor of VOCs coming into our homes each morning when the morning cool air is heavy and settles in the lowest parts of the valley. We do not have adequate health monitoring or health impact assessments to precisely know our state of health in Mountain View. Still, we know that there is asthma, heart disease, cancer, emphysema, and other pulmonary illnesses in most households here. And while many factors determine the community's baseline health, the industrial VOCs significantly add to the problems. None of the dangers of the gases from oil and gas operations in our area are monitored. When I was a little girl in the 1950s in Los Angeles, I suffered from asthma caused by ozone. I remember all of the sensations that go along with breathing in too much ozone. Until the past few years here in Albuquerque, I hadn't had those sensations since the 1950s LA. My parents moved me out of LA to protect my health. I think of all the kids in Mountain View who don't know why it hurts to breathe. And so I encourage you, and my organization encourages you, to consider the community level impact of inadequate monitoring and regulation of the precursors to ozone, and to remedy these dangerous impacts on public health. We are desperate for additional oversight and regulation. We support the EIB finalizing strong rules that include requirements to protect all communities near industrial areas that generate ozone precursors, particularly in oil and gas producing counties, but also at the end of that line where the oil and gas is transferred and travels outside of our area. The recommended measures will help protect all impacted areas of our state that now suffer from a disproportionate amount of environmental and public health fallout from the industries that contribute to ozone. Thank you very much.
Thank you, Ms. Painter. Let me go now to Mr. Jones. There you are. Can you hear me, Mr. Jones?
Yeah.
Will you speak up?
Yes, I can.
Oh, good. There's your voice, loud and clear. If you would please spell your name.
JOHNJONES.
Thank you. And if you would raise your right hand, do you swear or affirm to tell the truth?
I do.
Thank you. I'll start your 5 minutes now.
Ms. Orth and members of the board, thank you for this opportunity to speak on this important environmental and economic issue.
Hold
And
on, Mr. Jones. I'm sorry. Mr. Jones, I'm sorry to interrupt. I'll start your minutes again, but you faded and we couldn't hear you.
I apologize.
Please start again.
Ms. Orth and members of the board, thank you for this opportunity to speak on this important environmental and economic issue. My name is John Jones. I'm retired, but professionally I've managed community water systems for 21 years, a heavily regulated industry. I adamantly support regulatory oversight because it helps with industry safety and in the public having faith in those processes. But not every well-intentioned regulation is a good one. Increasing 35 new administrative requirements on small producers is going to be counterproductive. We have a collective duty to both the environment and in filling the coffers of the state. Requires balance. As a water professional, I support treating and cleaning produced water, and I oppose anything that inhibits the progress in developing those technologies, particularly in a drought-stricken state. Oil and gas has been proactive in developing those technologies to clean up produced water. Encourage them. Allow for diverse technologies. Don't tell them how to do it. Encourage them to do it. Not disproportionately target small producers in the methane rule. Oil and gas producers are leading the development of technology to limit emissions and reduce their environmental footprint. Encourage them. Thank you for your time and for your service to the state. Thank you very much.
Thank you very much, Mr. Jones. Let me go to Anna Rondon. There you are. Hello, can you hear me?
Yes,
I can hear
yes.
you. If you would
Can you
spell
hear
your
me?
name,
Okay,
please.
thank you so much. Thank you for the environmental
Excuse
improvement.
me, ma'am?
Can you hear me?
Yeah, I can. I need you to spell your name first.
Oh, Anna, ANNARONDON.
Thank you. And if you would raise your right hand, do you swear or affirm to tell the truth?
Yes, I do.
Thank you. I'll start your 5 minutes now. And if you would project more so we can make a transcript of your comment.
Okay, thank you. Well, thank you to the Environmental Improvement Board for having this space for the public to comment. I am speaking to you as a private citizen. I am a Navajo woman, grandmother. I've lived in the Northwest New Mexico mostly all my life and have children and grandchildren and relatives that work in the industry up around the Counselor, New Mexico area. And I just wanted to bring a couple of different perspectives. Our communities, along with this industry, also have problems, social issues with the man camps and also the accumulated impacts of oil, gas, coal, uranium mining, and the Gold King mine spill up in Northwest New Mexico. So with all of these industries contaminating and of course bringing energy and to the American people, but still we suffer. Like previous presenters this morning talked about the school, the child well-being, we're 50th in the country, but still in education also we are at the bottom of the list. So it seems that the revenue coming in from this industry is really not making an impact on the success of our children. So either they give more money or also to replace the revenue for education with upcoming cannabis taxes that can be replaced this industry. I support this methane rules that will protect our people, all people in the state. And I understand the economics of it, and a slow transition would do our state very well. And also creating jobs and doing the retrofitting to capture the methane gas. And just a reminder that we were very famous of having a methane cloud seen from NASA. And, you know, we do have the evidence that our people are getting sick and don't have the proper health care as well. So in public health, it's a major issue on how we generate money, at whose expense. So that also needs to be balanced as well in the social justice realm. But thank you all, and thank you for hearing my comments. Akiha.
Thank you very much, Ms. Rondon. We have come to the end of the list of those who reached out to offer public comment at the 1 o'clock session today. So we will return to the technical case. If you're on the platform and would like to offer public comment, there are 9 o'clock, 1 o'clock, and 5 o'clock sessions every day. So when we broke, I believe we were going to move from Nemoga's witness, Mr. Smitherman, to Nemoga's witness, Mr. Meyer.
That's correct, Madam Hearing Officer. Adam Meyer will be our next witness.
Okay.
Hello, I'm here. Can you hear me?
Yes, we can hear you, Mr. Meyer. And Madam Hearing Officer, he will need presenting, and she's nodding yes. And Adam, Mr. Meyer, could you please state your name for the court reporter?
My name is Adam Meyer. Last name spelled M-E-Y-E-R.
And you've previously submitted your testimony and adopted it in Direct Exhibit Nemoga A2 and Rebuttal Exhibit 42. Is that correct?
That's correct.
Are there any changes you need to make to your testimony in those parts?
No.
Okay. Did you prepare a summary of your direct and rebuttal testimony?
Yes.
Would you like to share your screen?
Sure. Can everyone see that?
Yeah, can you make it bigger?
Right.
And perhaps
Is that acceptable?
yes, that's great. If you want to move ahead to the pneumatics portion.
Absolutely. Okay, well, first I would like to start off talking about a summary of the effort related to the pneumatics that Valor conducted. There was 2 separate reports that were provided. One of them was on the emission factors, where we highlighted the latest studies on emission factors from pneumatic controllers. And the second one, which was more comprehensive, was a cost estimate report that actually took into account the current market costs during this I wouldn't say post-COVID time. And of course, then there's storage vessels, which we'll get to later on.
Why don't you proceed and tell us about the first step that you did, which was to look at the emission factors. What types of studies did you consider and what were your conclusions?
So the Valor team took a very simplistic approach to this, which was to gather all the studies that we knew about that tried to quantify emission factors. And specifically, it came down to the intermittent pneumatic controller discussion. And we compiled them and evaluated them and used that as a kind of a reference, providing that reference to say that in our estimation, we recommend using, kind of following in line with what Colorado has done and adopting that 3.5 standard cubic feet per hour for an intermittent controller. And it was a very simple study.
And as part of that evaluation, did you consider prior critiques that Dr. McCabe had made about some of those studies? And was one of the things you considered attached as exhibit appendix A to your exhibit A2?
Yes, I think, there was a report that was appended to that memo to just kind of illustrate in our perception that this was the latest and greatest information that we had, and that the 3.5 is a more appropriate emission factor. And I think a lot of this will come to light in a lot of the Surrebuttal testimony.
Okay, why don't we move on then?
Okay. So a lot of this is, I have a few slides here to kind of wrap my arms around the bigger effort that we did. And so portions of this will be anecdotal, so I apologize for that. What we were chartered to do was, based on the time frame we had, was not to do a full comprehensive state of New Mexico evaluation of the costs. What we did, what we thought was the best use of our time was to piggyback off of the ERG and MED cost analysis and make adjustments as we thought were more appropriate to the current market place in terms of equipment and installation costs, and try to correct those where it was applicable. Part of that too was we believe that the ERG cost estimate was quite impressive. I must say that it was a very good cost estimating exercise. And to me, the most important thing when we evaluate cost estimates between individual A and individual B is to try to compare apples to apples where we can. And so therefore we just use the NMED cost estimating sheet as the first step. So what we did through that process is we incorporated this emission factor of 3.5 scuffs per hour for the intermittent controller. And that was a simple change. And, update the sheet appropriately. And then what we did is we conducted a series of studies gathering vendor information on the various configurations we could think of that may be instituted at some of these production facilities, midstream facilities in New Mexico. So you see here I have a couple bullet points describing facilities that need to be converted to instrument air, for sites that have access to electricity or have it on site already. Conversion when they don't currently have electricity on site. The next one being, what is the cost associated with, say it didn't have access to electricity at all, any grid power, how would you power those instrument air compressors? And so we evaluated a generator and solar hybrid combination and how much that would kind of cost. And then the last one was, completely going to solar power for all your instrument needs. And so for each of those kind of categories, and I'm sure there's other hybrids and more, what we did was, provide latest vendor information and tried to keep everything as consistent as possible with the NMED cost estimating sheet. To the point where there are costs associated in that sheet there are features in that estimating sheet that we don't necessarily agree with. For example, the time to pay back, with 10 years and an interest rate. We don't believe in that, you should be looking at a 10-year payback for these facilities. But again, that would have added another variable that we weren't trying to focus on. There's other instances you see here, 5 horsepower, 15. One of the things that the cost estimating sheet that ERG did was where it was very impressive as how they broke it down by the number of pneumatic controllers and the horsepower of a compressor that would be required to supply that. We gathered costs and vendor information for those similar sizes.
Okay.
So one of the biggest kind of deltas was between the ERG cost estimating sheet and the updates we made is based on the vendor information, vendor quotes, right? Hard vendor quotes that we received from working these projects for years. And the air compressors always seem to be the delta. And the thing to take away from this is this is not your Home Depot air compressor. It's different. There's more to it. There's more bells and whistles. And to the point, like, there's also not a standard, there's not a linear cost per horsepower once you get to a lower threshold. So for example, if I needed if I calculated I needed a 3 horsepower, maybe the standard one that's available is 5. And the things I need to go with that are all pretty much the same. Even if I went to 15 or 30 or whatever, I still need a building. I still need to protect the system. I still need to wire it up. I still need some steel to support it, electrical panel, and then of course all the piping and tubing that go with it. So, I mean, it's very much like you're, buying a car. You can buy the standard package, starting at price of this, and then you add on your leather and your features like that. It's very similar. It's not linear with horsepower. So other things that we added to this were installation costs. Crane, there's things to consider like personnel time and crane time. And I think you've heard from other testimony that, trained personnel are kind of short in supply. And I have on here BOP, which means balance of plant. For anyone who doesn't know, that's basically everything around the building, around the air compressor, piping that I need to hook up to it, or electrical or instrumentation if I need to monitor how well it's performing. So we added those costs into the spreadsheet and came up with something significantly higher. One of the things that we have been dealing with a little bit is, when we switch over to instrument air and air compressors, there is this, we've sort of introduced a single point failure into the system. A lot of facilities that are on instrument gas or, fuel gas, sometimes the pneumatics are taken off of the separator that they're servicing, or maybe there's a combined fuel gas system that just goes to a passive vessel or knockout that then services all the end devices. And there's a little bit of a fear right now with converting to a system that has a single point failure. And I bring that up there was a minor delta, I think, in some that you'll see in some rebuttal, that was that, the cost for a 60 horsepower instrument air system is almost double than I would have thought. And the reason for that is because, usually if you're in that range of size of compressor, you're servicing a much bigger facility. And if that bigger facility goes down due to a single point failure, you've got bigger emission problems, such as any kind of emissions from restarting a system to blowing down equipment, emissions from tanks if there's thermal breathing losses. So with those bigger facilities, sometimes if there's a fear of single point failure, we recommend to put in a redundant compressor that's on standby. So we call them like 100% compressors, meaning each one of them can handle the facility, but they're redundant to accommodate for a failure. Other things that we're kind of seeing is looking at with instrument air is the reliability of the grid. And, that just kind of goes along with single point failure discussions. And, what happens when that system goes down? All these things have to be considered when we are designing these systems.
So your basic point here is that the expectation of certainly the company that you're working for certainly the agency and the surrounding public is that control systems should work and they should work all the time.
Yeah, and that's right. And ultimately, you know, I'm a service provider, right? So I always have to recommend for redundancy or providing a little bit oversizing of equipment, because if I'm wrong, usually it's on me and my team. I don't want to get the phone call at 11 p.m. So another point that was in the Valor memo regarding, you know, conversion was to like a completely electric actuated valves and dump valves on separators and basically everything. Now, you know, I personally have some issues with that, only because we have to consider these valves and the process condition that they're serving, that we want them to fail safe. When we say fail safe, it's usually like you lose pneumatics, the valve closes or it opens, depending on if it's a normally open valve or a normally closed valve. But all these things we have to, the fail safe state is really what we have to consider. And in addition to that, we have to consider actuation time. How fast do we want this to open, and how fast do we need it to close? All those things take a lot of thought, and if you have a valve, for example, that is a bigger valve, requires a high demand, needs to open quickly or close quickly, you have to, and if we were to convert it to electric, you know, there's an immediate quick amperage draw. You know, it requires a lot of current to actuate that valve. So in my experience, most people are very just, you know, it's either instrument air conversion or nothing if they have to, right? So I'm a little hesitant, you know, me personally, I don't recommend electric actuated, you know, for many reasons, and including, but mostly from the fail-safe perspective. The other consideration, similar to the instrument air compressor, is, you know, we've got a lot of, well, let me first say, you know, it's not just we got to convert an actuator to electric. You also have to convert the level controllers and basically pressure transducers that were pressure gauges. A lot of instrumentation go along with actuating one valve. You know, you've heard in other testimony that, you know, these valves are controlling something. It's either, you know, pressure, temperature, flow rate. So the corresponding measurement device also has to be electric in most cases. So the cost is not just the cost of the actuator. There's more to it than that. And then I have to tie all that together into some control cabinet where the valve comes, leads come into, and the level controller, the electric level controller leads come into, or pressure. And those PLC cabinets can get very expensive pretty quickly. And they too have a bottom line cost, right? You need a cabinet, you know, you need what they call DIN rails, which are where all the controllers come into on these I/O devices. Those PLC cabinets run upwards of $10,000 or more easily. Okay, then we talk about, you know, we had talked about in there solar. When you're talking about solar, it's very important to, it's not just you have solar panels that power these things directly. They go, you know, they provide power to that PLC cabinet that then provide power to the end devices. Now, what if you had a, you know, a snowstorm or cloudy day, right? So you actually have to design and have a battery backup. You know, the batteries are usually put in battery boxes that, you know, they have to be sized, you know, you have to size them for the appropriate amount of days of autonomy, as we call it. So if you want to size a facility that it can handle 5 days of cloud cover, you have to have enough batteries to last you that entire time. So there's a lot to consider. And of course, all those devices, the control cabinet and the battery box, all those need to be mounted off the ground. And so that requires some structural and some civil work. So the cost for all these things, if you just look at the cost of an actuator, electric actuator, that's just the tip of the iceberg when it comes to facility design. And again, just like the instrument air compressors, you've got a lot of single point failures in that system, right? You have breakers and fuses where if they too fail inadvertently or by design, it kind of would require, you have a facility shut down and same consequences as the instrument air system. You could be having more emissions from thermal breathing than you probably would have saved just keeping it on instrument gas. Now, how you quantify that is kind of up to the facility engineer to do that. But these are things that we all have to consider when we're talking about major infrastructure change like this. And I believe that concludes my direct, Mr. Heiser.
Okay. Did you also prepare some Surrebuttal?
I did.
Why don't we go ahead and take this down and switch to that, and we will do your Surrebuttal as well.
Oh, I stopped sharing. Oh, there it is, the big stop sharing button. Okay.
And so the first part of your Surrebuttal, then you evaluated some of the commentary that you received in rebuttal from the other parties, challenging whether the 13.5 or 3.5 standard cubic foot per hour, which sometimes you call a scuff per hour, and this is your evaluation of that testimony. Is that correct?
Yes, we start off with that. Yep. Did you have questions? I'm sorry.
I mean, what did you conclude based on the commentary from Dr. McCabe and others?
I guess the conclusion of which kind of plays to this is, which one is more suitable. And, I will say that I just inherently have always had issues with these emission factors in terms of several reasons. One, because there's no kind of distinction between malfunctioning versus as designed emission factor. In addition, I understand there's always a statistical approach that is always taken. We're going to go evaluate all these facilities, all these pneumatics, and try to quantify an emission factor. But as a kind of designer of facilities, I would say that there's a lot that goes into determining that. I think you pointed it out earlier where you weren't sure if a couple of data points were malfunction or properly operating. But what things go into evaluating, how much, what is the consumption of gas that a pneumatics valve uses, right? There's several things that go into that, and I never see any studies that talk about that. And so the problem becomes, if you take this statistical approach to evaluating all the emission factors from all these devices, but then you try to use that as to say what a root cause is or why something is lower in one state versus another. If you don't know how the system is operating, or for example, is it on a plunger well or not? And I'll get to that later. How can you say, it's applicable to one state or another? So to me, my thought, and this is on this slide, is that to my knowledge, there's no studies in New Mexico that would evaluate pneumatics from a facility engineering perspective. So until that time, I consider both of them arbitrary. So with the pneumatics memo that we put together was just to highlight the latest studies that were done from an environmental engineering perspective. But to this date, nothing's really satisfied me in terms of from a facility design perspective. I guess I'm halfway through the slide, so I'll just keep going. So, I think Dr. McCabe had said that, in some of his rebuttal testimony that didn't believe the 3.5 was appropriate, that 3.5 scuffs per hour was appropriate for Colorado because of, more regulations, more frequent leak detection and repair, and just a general more awareness of emissions in Colorado. Which brings to the good, my fourth bullet here, which is if we were to implement the similar stringent LDAR at these facilities in New Mexico, wouldn't we perhaps be, in a few years, be seeing that we are trending towards the 3.5 scuffs per hour? Again, not disagreeing with, not trying to dog any kind of statistical approach, but if we're talking apples to apples, I'm just going to talk apples to apples. So wouldn't we be potentially going towards more of a 3.5 scuffs per hour if this LDAR was implemented? But then another kind of point came to mind, which, a lot of these studies were done in, 2015, or at least in the past recent years, I'll say. And, with reference to Colorado, and from 2014 until basically now, there's been a big push towards closed vent system analysis on storage tank compliance, right? Producing emissions from storage tanks. Well, what people don't really know, or which me and my team members do know, is that during that time, we were recommending, and the operators were putting smaller valve trims all over the field. What that means is a valve could be a 2-inch valve, and it has a orifice size in it of 1 inch, for example. But to reduce the trim, you're basically reducing the orifice or the hole diameter that the fluid can go through.
And so basically what you're saying, Adam, here is that there were changes in how industry was designing and implementing some of this equipment that were going on at the same time as the LDAR developments that Dr. McCabe was speaking about.
Absolutely. And so as a result of the smaller trims, what you see is valves that used to say actuate, I'll just throw an arbitrary number, 5 times in a minute. And now with the smaller trims, there's less liquid going through it, less liquid flow rate. And so the valve would stay open for 1 cycle. So that I reduced that 5 down to 1 just by trimming down the valve orifice. So, to say that this is strictly LDAR, I don't know if that's true, but I do know what we were doing for the past 7 years has helped the frequency and the amount of emissions out of controllers. So I have a picture here to kind of illustrate that, because I know this is a little technical, or at least can be. But if I'm looking at a separator right here, and this is a certain design of separator where you have an oil bucket and a water bucket, as they call them, and the float kind of goes up and down in that area, in the level goes up and down in those buckets. Well, when the level goes up, it opens the valve, and when the float goes down to the bottom of its span, it closes the valve. So you can imagine that if I were to take that valve and put a really small orifice or choke point on the exit of it or inside of it, that when it hit that high level in the separator, it would take a much longer time for that liquid level to go down. And as a result of that, I took something that would have cycled, again, example, 5 cycles in a minute down to 1 cycle per minute. This is not intended to confuse anyone, but is to illustrate that as part of the closed vent system analyses that I've done over the past 7 years, that we gained, in my opinion, a much better understanding of pneumatics and how they work and how they, how the valve opens and closes and how the well behavior affects it. And so these equations were developed over time to best quantify number of cycles in a plunger run or during a normal operations. Now, they're not perfect because in real life you have slugging and unanticipated events, but at that same time, these have been proven up time and again with actual field data. So along those same lines, you have this, you have different types of wells and they affect, separators and valves in them, differently. So a free flowing well, if, you look at that previous slide, the liquid is coming into the separator at pretty constant rate, near constant. What we have observed from doing these closed vent system analyses and closed loop vapor control systems is, they can actuate for 3 to 5 seconds and close, be closed for 20 to 40 seconds. That's pretty typical. Again, not saying that every facility is like that, but that's pretty typical. And plunger wells are kind of all over the place. But what we do know is that when you have a plunger well that brings up a large slug of liquid at a pretty fast rate, again, going back to the trim size, if you have a small trim size, that valve will be open one time during that plunger arrival. So I say all of this to kind of demonstrate that maybe LDAR is not the only reason, or that heightened awareness of pneumatics is the only reason why maybe a Colorado emission factor of 3.5, why it was established at that. There have been other facility design changes in the past 7 years. So here on this next one is kind of a calculation, and I kind of think it's, maybe a little too much for this discussion. But the takeaway is that, you can actually calculate the volume of a volume within inside a valve actuator. And you can calculate that if I pressure it up to an X number of PSI of gas, you can literally just say, okay, when it depressurizes, it lets go of this amount. So what I noticed in the ERG cost analysis is that they use that 13.5 scuffs per hour as kind of like a total up for intermittent controller totalized over an hour. Okay, so you'll see here you have, I have an example of a 2-inch valve and the amount of volume that it contains. And over here in this, on this slide, what I kind of show is that with 13.5 scuffs per hour, and based on what we know of how much is actually contained in those valves have to cycle 135 times in an hour, or even the 3.5, 35 times an hour. Again, the 135 seems very unlikely to me based off of my observations and the testing we've done in the field. And even 35 is very unlikely. That basically means that valve needs to open for 1 second, close for another, open for another second, close for another. But, what we don't know from that 3.5 estimate is whether or not that's a failed condition or not. So again, what I'm trying to do is look at pneumatics from a facility engineering perspective, not from an environmental engineering perspective.
And from the facility engineering perspective, you're saying that given the sizes of the valves and the amounts of gas that are involved, and a reasonable estimation of the number of cycles, it's not going to be as high as some of these studies have suggested.
That's right. I just can't see it. I don't understand how how they came to these numbers. It also kind of plays to a little bit, just kind of a little aside, is that, this is a very good, opportunity for immediate emission reduction from pneumatics. Change the trim size on your valve so it doesn't cycle as often. That's something that is very, very doable. It doesn't require an entire instrument air system to do that. Okay, moving on here. Want to discuss a little bit of going back to the ERG cost analysis. Again, want to say that it was a very impressive study, so I don't want to dog anyone for that. There was just a few things that we're changing here, right? So here's a snip of that estimating sheet, and for 10 controllers, 40 controllers, and 100 controllers, NMED kind of calculated a horsepower requirement, for 4 horsepower, 16.1, 40.2. Now, we can't, you can't order a compressed air system in that, right, in that size. You have to round up to the nearest 5, 10, 15 horsepower. So what we did was we basically just, where it said 4 horsepower, we put in our cost analysis for a 5 horsepower system. And for a 16.1, we put in a 15. So we tried to echo everything that NMED did in terms of their assumptions in order to compare apples to apples. So another part of Dr. McCabe's rebuttal testimony, I believe, was, how did you come up with that horsepower? And, the calculations don't make sense. And, what I will say is that I've been designing all kinds of systems for years, and did 26 instrument air systems back at Kennedy Space Center. Did most of them for the Siemens gas turbine balance of plant systems, and of course have done that here in oil and gas. And what I will say is, in my travels, that all engineers do the math differently on how they come up with the required amount of instrument air, and by association, the horsepower required. So some of them do them based off of a known frequency, which is kind of how I like to do it, because it understands shows an understanding of the well behavior. Some people put a meter on the fuel gas system that they're currently using and then convert it, right? And then other folks, they work with the valve manufacturer, and they find out what the demand is for that specific valve, and they do a base load case of X number of controllers out of Y number of controllers that are out there, and they add in safety, safety factors and correction factors to it. I will say that I think, all are valid and all are appropriate. But the most important thing to look at is the demand. What are these valves requiring in a certain amount of time? So that requires a lot of process knowledge. You kind of need to know, what it's supposed to do, what do you want it to do, and so you select the valve, and then you estimate the proper opening time and close time for that valve, and you size the actuator and the vent orifice that comes off that actuator appropriately, right? I have an example here, but it's in general just trying to illustrate that, there may be valves where I need it to close in 1 second, but I don't care how long it takes to reopen. So depending on if that's on the demand or the exhaust side of the valve, kind of dictates, how I size for my demand for my instrument air system, and by association, what size horsepower system I need. The point I'm trying to make here with this is that I believe Dr. McCabe was trying to use the environmental engineering approach of these emission factors, these emission rates, to kind of extrapolate what the horsepower of an air compressor would be. But the point is that the demand rate is not the same as vented rate. because you need to know your specific process conditions and what your valve can do. So, you know, at the end of it, though, what I would like to illustrate again is that regardless of how Dr. McCabe performed the sizing, or me, or, you know, Joe Smith, facility engineer, really there's like commercially available electric motors. You know, you can't just get a 3.15 horsepower air compressor. You size your system, you add a certain safety factor, and then you round it up to whatever is commercially available. And I think NMED, you know, almost got to that point, but they got close. But it's basically the cost estimates we have put in there were based off of those rounding to the nearest 5, 10, 15, et cetera, horsepower.
Is that your final slide, Adam?
I believe so.
Okay. So the point that you were trying to make through this for the board is that you tried to look at the actual requirements for system design in coming up with your cost estimates?
Yes, and to basically vet the NMED assumptions of the 16.1 horsepower and those things, and we found the commercially available ones that were in that range. That's how I did it. Again, so we could compare apples to apples.
So that you were using the commercially available equipment that you could actually go out and buy, correct?
Yes.
And that you also try to add into the cost where appropriate the other parts of it in installation that are required, things like tubing or logic controllers, things of that nature that are part of any of these system designs.
Yes, with one caveat that we kept installation costs at 50%. You know, basically man hour, crane time, that kind of thing, kept that at 50% of the capital cost. And we did that, again, not that we agree with it in all cases, but that is what NMED used. And so, again, trying to eliminate the number of variables we're trying to debate here.
Okay, so you did not include some of those costs. You accepted the 50% of the total cost.
Correct. I didn't go out to quote formulate for any mechanical contractor and what their bids would be.
Okay.
So.
All right, well, thank you for that. Probably more than anybody wanted to know about facility design.
I'm sure.
But hopefully that will answer questions from board members about some of the factors that go into these decisions. Madam Hearing Officer, we're happy to provide Mr. Meyer now for questions from other parties.
Thank you, Mr. Heiser and Mr. Meyer. Parties, council, if you have questions of Mr. Meyer, please turn on your camera.
Madam Hearing Officer,
Mr. Bach. Sorry.
Can you hear me okay?
Okay, yeah, you're going to have to lean forward, though.
Thank you, Mr. Meyer. Very interesting stuff. I will do my best to try to make sense of it. So I'd like to start by going to a point I think was on your very last slide there. And I'm trying to understand this. I think you said demand rate is not the same as vented rate. Is that correct?
Yeah.
So we're just trying to understand this because as you alluded to, Dr. McCabe in his analysis said, you know, went through and looked at the capacity of these compressor systems that were included in the economic analysis and said, well, it looks like they're producing, you know, in some cases 30 to 80 times the amount that is actually going to be vented from the controller. So it seems they're oversized. But your point is that that some of the air is not you need some air that's not going to be used to actually actuate the controller. Is that correct?
I think I know where you're going with this, and if you're okay, I could. The difference becomes in how we talk about rate, right? The vented rate, the immediately when I depressurize that actuator, what is that instantaneous rate, right? What is that flowing, right? Versus if I total up the amount of gas based on all the actuations from that valve in an hour, what's the volume in that hour, right? I think that's where the discrepancy is a little bit. And what I was trying to illustrate is that that momentary rate of bleeding off is that instantaneous rate is not the same as the demand, right? If I need to pressurize all these valves very quickly, but I don't care how quickly they bleed off. Does that make sense?
I think it does make sense. So my question then is, could you use a tank? Could you store this compressed air so that you don't have to be generating more than 40, 50 times more than you need?
Yeah, absolutely. So yeah, most compressed air systems have an accumulator or receiver that are there, so you're not putting too much of the demand on the air compressor to operate immediately, right? But at the same time, I still need to replenish the air that was in that receiver that was used in pretty quick order, right? And again, going back to the difference in the service world, right? I always err on the side of conservatism when sizing these things, and most people do. Because the last thing I want to do is get a call that all my valves stopped because my air compressor has been running around the clock and overheated and shut down.
I understand that, and I think this is a helpful clarification. But I would push back on that and say, do you think it's standard practice or good economics to have 80 times the amount of air you are going to use over an average period? Is that maybe going a little too far in terms of having redundancy?
80 times based on what? The bleed rate?
Right.
That's not correct. You put in a demand rate based off of the instantaneous flow I need to pressurize that valve. And then you add a safety factor on top of that. And then unfortunately you round it up to whatever's commercially available.
So, but I thought with the tanks that the instantaneous rate was not, because you are able to store it. I'm not sure why the instantaneous rate, why you can't use the average emissions over an hour and say, well, we're gonna generate that much air, so we have that much in the tank.
Well, some people, again, to your point, some people do in a very quick hurry when they don't know what the process needs are for that specific valve. They throw in an assumption, 1 cubic feet per minute or whatever it is. They do an estimation of, base load and peak, right? And then they add a safety factor onto that. But at the end of the day, it's very important to keep in mind that, you can't go buy a 1.15 horsepower air compressor that's commercially available. You usually have to round up to the what is available. And again, the costs for that there's a base model, and then you add additional horsepower.
No, I totally get that you can't, necessarily custom order a particular, 17.3 horsepower or something. I get that. But I guess my point is, it still seems like, the calculations here are assuming either that a lot more gas is bleeding than the emission rates suggest, or that more, many times the amount of gas that's actually going to be needed is being produced. And I understand, that it's there's some complexity there, but it seems like perhaps that could be addressed as folks become more familiar with the system, and they could say, well, we don't need to be producing 80 times the amount of gas that we're actually using on an hourly basis. I don't know if you would agree with that.
No, not the 80 number. I'm not quite sure where you keep getting that from. But I understand where you got it from, but I don't understand why that's stuck. Again, it all comes down to your process conditions, and I can't explain every single circumstance where you may need a higher demand, or hey, maybe there's a pneumatic pump involved, right? An AOD pump, right? Consume 25 to 50 scuffs per minute. Could be huge demands, and we also have to size facilities not right on the line of demand. We size exactly for the demand if we could. We got to also size for expansion. right? If they're adding another well in the future, if they're adding, whatever, we have to be prepared for that. And unfortunately, I mean, I understand where your line of questioning is coming, but there's no simple answer. Does that make sense? It depends on the facility and the demand.
Understood. And just for the board and others, the 80 times is coming from Dr. McCabe's rebuttal testimony, pages 15 and 16, where I think we did analysis. And yeah, I don't know if do you recall, Mr. Meyer, reading that discussion?
Yeah, I had reviewed it briefly.
Yeah, so I think the discussion there was that looked like with a 60 horsepower compressor, you'd be getting about 113 scuffs per hour per controller, which is about 80 times the emission rate that you would use. So I think we've done some good discussions there. I wanted to also ask about the emission rates. I think that you would agree that the emission rates that are used are a big driver in terms of the overall cost of the program, right?
I think a lot of things are, but yeah, yep.
I think I heard you say at the beginning of your presentation that it's really, there's no way we can know for sure what the bleed rate for intermittent bleeders is in New Mexico because there haven't been New Mexico specific studies. Did I get that right?
Not to my knowledge, at least I have not seen them.
But I characterized your testimony, right? That was your.
Yeah.
Right. So, and you agree that the emission rate here could conceivably be higher than what was used in Colorado for an intermittent bleed controllers, right?
They could be if we're adding malfunction into it. Yeah. If there is significant malfunctions, statewide, that would lead to a larger emission factor. And if we are, defining emission factor as both the design vented rate as well as any malfunction, then yeah, I would support that.
And you agree that there are malfunctions.
Oh, absolutely.
And in fact, the literature documents that at least in certain basins that they're quite common.
It is common, but that's why we have those other programs to catch them and fix them, and like Colorado did, and like we're going to be doing here.
Is there any reason if the controllers are malfunctioning a lot and emitting more than their design bleed rate that you would not factor that in when you're trying to design this program?
When you're designing the what? I'm sorry?
So when you're trying to do your cost analysis and you're trying to say the cost per ton, is there any reason you would not use the emissions that are actually happening in the field? I mean, would that be good practice?
Well, when it comes to, cost per ton. So the cost per ton analysis is based off of an emission factor, right? As well as all the equipment that's associated with it. So, I mean, to me, the equipment costs dwarf any kind of, pretty much everything. I mean, a compressed air system is going to cost you at least $100,000, if not more, total package. So I guess I'm not quite sure where you're getting. There's a lot of factors that go into that cost per ton, I would say, in addition to the emission factor. Is that what you're getting at?
Well, right. But to know the total number of emissions that you're going to be controlling by the rule, the emission factors is how you get that, right?
How I get there. Yeah, that would be a starting point for sure. But again, I fundamentally disagree with not understanding how a plunger well list, works, or how you can change the air set on a pneumatic valve to reduce these emissions from the beginning. This is, I don't know if that makes sense, but switching to instrument air may not is not cost effective for some of the stripper wells or low producing wells, right? And so emission factor really doesn't play in too much, I would say, into that. More of the equipment cost is a bigger driver.
Well, I thought that the analysis that you did was looking at cost per ton and looking at how NMED evaluated that. And so
Yeah, again, I was being very specific just now to smaller producers, right? So, but yeah, as a industry whole, yeah, the emission factor would play into it.
And so if you're trying to find cost per ton, the the amount of emissions is the denominator, right?
Mhm. Yep.
So if you're not using the right emission factor, then your equation is not going to be right. That's
Well,
why.
neither's McCabe's, Dr. McCabe's. If he's using a higher one, that's not correct, and I'm using a lower one that's theoretically not correct. Neither of us are correct. That's why I said they're both arbitrary until we do a study.
Okay, but your testimony is that that
And from what I'm saying is from a facility engineering perspective of looking at valve demand, something doesn't add up. I need to be cycling a valve once every second. Doesn't make sense to me from a non-malfunction perspective.
right, but again, you reviewed Dr. McCabe's testimony where he said that malfunctions are incredibly common, did you not?
Yes, but it was more cost effective to go from a 5 horsepower compressor to a 30 or to fix my level controller, right? Think about that. So there's a certain amount of leakage that you actually, incorporate into sizing a system, but I wouldn't automatically just go up and say, I need a bigger horsepower and I'm not going to fix my leaks. So the LDAR program is going to fix those, are they not? That's what I thought.
So, I think that the
Maybe I misunderstood you. Did I misunderstand you?
So I think the testimony about the LDAR program is different, but I'm just trying to say that, when we're looking at where we are now, we're trying to figure out the costs and benefits of this program as a whole, including the LDAR and the conversion. Does it make sense to ignore the fact that there are a significant number of malfunctions? Because it's not, I'm trying to understand why we would use the idea of what they emit when they're correctly operating if the evidence shows that they do not correctly operate much of the time. Maybe you can clarify that.
You're asking why wouldn't I incorporate into the cost assuming that they're all malfunctioning?
No, they're malfunctioning at the rate that these 15 studies that we cited suggest they are.
That Dr. McCabe was saying the 13.5. Why wouldn't I incorporate that? So that would be on the low end, right? So what we can easily do is update just the equipment cost in that cost estimating sheet. And even then it's about 2 to 2x higher than what was projected by NMED originally. So let's put that, a good point to let's put the emission factor to the side. Then the cost estimating sheet would still show projected higher costs per ton based on just the equipment alone.
Mr. Meyer, in your analysis, you did not include the value of the saved gas, did you?
Value of the saved gas? No, and NMED did not either. They showed it, but I don't think they took credit for it, if I recall.
And the emission factor would also bear directly on that, wouldn't it?
I think the emission factor would bear on, if I changed it to instrument air, it would have 0 emission factor, correct?
So what I'm saying is that the value of the value that you're saving depends on how much you're currently leaking, right?
Yes, in theory.
So if your analysis assumes that they're currently leaking, and I have a number of different numbers here, but I think for intermittent bleeders, you said, what was it, 3.5? Is that what you said?
Yeah, that was the recent one, yeah.
So if your analysis assumed that you're leaking 3.5 scuffs, and I'm glad I know that they can just say scuffs, it's easier. If you assume it's 3.5 scuffs per hour, but it's actually 13, then the value of saved gas is almost 5 times higher.
Yes, but I think that Mr. Smitherman has already gone over that. That part wasn't part of my assessment in terms of how much you would be saving from a higher bleed. But I think Mr. Smitherman did. And still the payout wasn't quite there. And I think people generally agree with that. I'm just speculating though.
Okay, but that, again, just to be clear, that was not, no form of gas saving.
There's a lot of things in that.
Hold on, gentlemen, you really do have to speak one at a time.
Okay. So there are a lot of parameters, I believe, in that ERG NMED spreadsheet that, given the time, I think that, maybe there could be future discussions on refining that. But we did not feel, based on the time and also based on what we know, right? So what do I know? I know how to size systems and I know how to get vendor quotes. So that is what was relevant to my study. Extrapolating that out to how much gas is saved, to your point, that is nothing that I did.
Mr. Meyer, if you were considering a retrofit for a facility, not in the emissions context, just as just a project that was desired for some other reason, would it be standard practice to look at, value of gas that you might capture that you might not otherwise be able to capture?
No, usually because I think it's understood that the amount of gas that you captured is a fraction of a percentage of what a facility would make, and that you can't justify that gas that you sell is going to pay off the equipment. So really, most of the drivers we're switching over to instrument air, either for compliance reasons or otherwise.
So your testimony today is that the oil and gas industry does not consider the ability to increase the product it's going to sell, deciding to upgrade infrastructure.
No, well, for me, all I can talk about is the projects I've dealt with where that hasn't come up in discussion. But I can't speculate on other operators. Maybe they are down to that fidelity.
So if a upgrade 50% of the cost might be paid for just by the retrofit, that is not, in your testimony, is not something someone would consider.
If 50, can you rephrase it? Can you say that again, sir?
So I'm just trying to give you an example. So if you have an upgrade that you want for some other reason, and you're comparing, say a piece of equipment broke, and you want to upgrade the equipment, and one piece is going to have a slightly higher cost, but is going to pay for itself in gas savings over 3 years. That's not something that would be considered. Is that your testimony? I'm trying to understand.
That's not what I'm saying. I'm saying the projects I've been dealing with, usually the cost savings associated with switching to instrument air isn't brought up in discussion.
Right. I was asking a hypothetical, not necessarily instrument air versus anything else, but just in general, if that is something the industry considers.
So as a hypothetical, if a client of mine says that we want to install XYZ because we've calculated that it pays itself back in 3 years and then we're making more on gas, are you asking would I do it? Sure.
Well, no, I'm asking is that something that people would consider? Is that not part of the analysis when you're looking at equipment upgrades, that the ability to capture gas?
It hasn't been a part of the analysis on projects I've been involved with. On a future project, if that comes to my attention, if that is their driver and that is their driver for doing it and justification, then great. But I can't speculate on how people have done things on a hypothetical future project. Am I not hearing you right?
Yeah, I mean, I guess I'm just trying to understand from the perspective of operating a business.
Madam Hearing Officer,
Mr.
been
Heiser.
asked about 5 ways the same question, and his basic answer is, I don't know what my clients are deciding on this issue.
Yeah.
Madam Hearing Officer, I think the witness is being evasive. This is a very basic question, whether industry considers the value of the product that they're saving I don't know why I can't get a straight answer.
All right, so I don't think the witness is being evasive. I think he has answered as to whether it was a practice of clients in the past in that regulatory landscape or product landscape, and has acknowledged it might change in the future. But I don't think he's being evasive. Do you have other
Okay.
questions, Mr. Meyer?
One other question. This relates again to emission factors. Mr. Meyer, in your analysis, I believe you used the Colorado estimate for intermittent bleed. Is that correct?
Yes, as I understand it. Yep.
And did you use the Colorado emission factor for low bleed?
I did not change low bleed or high bleeds at all.
No further questions. Thank you.
All right, thank you, Mr. Bach. If you're another party with questions, Mr. Meyer, please turn on your camera. Not seeing anyone. In that case, I'll turn to the board for their questions. While I'm doing that, if you're an attendee on this platform and have a question, please reach out through the chat. Madam Chair, do you have questions of Mr. Meyer?
Thank you, Madam Hearing Officer. I don't have any questions at this point.
Thank you. Vice Chair Trujillo Davis.
Yes, thank you. And thank you, Mr. Meyer, for your detailed testimony. And I apologize for the directness of this question. I was just curious if you could just give us, the board, just some quick bullet points of like a summary of your presentation. I just want to make sure we didn't miss anything.
Okay, sure. Yeah, there was a lot there, wasn't there? So the kind of the highlights of it were, speaking strictly from the emission factor perspective, Valor thought it was prudent to use the latest studies. So that was used as part of the cost estimating adjustment. In addition, we evaluated the various ways to change over to instrument air or electric driven systems, and found that the costs based off of the current market right now, post-COVID and ramp up of the commodity price was much higher than what NMED had predicted. As part of the rebuttal testimony, most of it was defending how the summary is that defending how, one, there are more emission factors, in my opinion, from a facility engineering perspective, is much more complicated, and it takes someone with an intimate understanding of wells, production, and the process in order to ascertain a correct emission rate, malfunction excluded. And the second part of the rebuttal was justification for sizing of equipment and how you actually size instrument air systems, and providing technical detail for that.
Thank you. I appreciate you just summarizing it for us real quick. And I think if I have any more questions, I'll be looking through your presentation. So thank you.
All right, thank you. Member Cates. Member Blitzer.
Good discussion. No questions. Thank you.
Thank you. Member Duvall. Member Garcia.
No questions, thank you.
Member Honker.
No questions, thank you.
Thank you. Let's see, I'm checking the chat. I don't see a question there, although I thought I might get one there. Madam Chair?
Yeah, I appreciate your testimony, Mr. Meyer, and the extensive cross and also Vice Chair's question. So given the summary that you provided in response to Vice Chair's questions, so really it just sounds like we don't have really good estimates here in New Mexico as to the emission rates. I mean, the studies that were provided were for other facilities outside of New Mexico, and we have yet to do those for New Mexico, is what it sounds like. Is that accurate?
Yes, to my knowledge, there has been no study to my knowledge. And based on how other studies have gone, I would do them differently, basically.
Okay, so and then just so I can get my head around it, so in those, say you were able to do the studies differently, you still have questions about how other studies were done. Is that correct?
Well, yes, it is correct from the perspective of how a facility engineer sizes systems and analyzes systems versus an environmental engineer. I think it's just two different disciplines, and to provide accurate cost estimate and value summary, I would need to have it be viewed at from a facility perspective. If that makes sense.
Okay. It does, and I mean, it's like 10 different lawyers will look at the same piece of paper 10 different ways. Like you said earlier, 10 different engineers will look at a system 10 different ways.
Absolutely.
So it's just, yeah, and it's just what we look at as the assumptions and, what we're modeling, and then of course, the details. So I appreciate your perspective on this, Mr. Meyer, as well as the others that have provided that their perspective as well. Thank you so much.
All right, thank you. I did get, Mr. Meyer, I did get a question in the chat from Mr. Herndon. It seems incongruent that his company doesn't consider the value of the lost gas in their operations, but they consider the value of replacing those systems, which would, without argument, save them product and money. I know you had this discussion with Mr. Bach, or a similar discussion with Mr. Bach, Mr. Meyer. Would you have anything to add?
Yeah, only from the perspective of that, I'm not an operator. I don't make the decisions as to what drives change at a facility. I can recommend and advise my clients on what is best for reducing emissions while remaining cost effective. That is my role. That's what I do. At the end of the day, though, it's ultimately the operators, oil and gas companies' decision as to why they change something or why they don't incorporate, why they don't account for captured revenue from the gas they would have lost. I'm, all I can do is be a good, servant of my client and do right by them.
Thank you very much, Mr. Meyer. And I'm sorry, Teresa, Herndon was Herndon. Mr. Heiser, does any of that prompt for you any redirect?
I think just a little bit on maybe 2 points, Madam Hearing Officer. So, Mr. Meyer, you testified that you reviewed a number of studies, including one from Dr. McCabe that was attached as an appendix to your report. Is that correct?
We compiled the studies and reviewed them in a very high level perspective. I'll let you answer the rest of your question. Ask you the rest of your question. Sorry.
And in the report that you included as Appendix A to your expert report, the one from Dr. McCabe, was one of the things that caught your attention in the report that Dr. McCabe looked at the question of malfunction and putting those malfunction emissions back in to the emission estimates in one of the other studies.
I did not look at it from that perspective. I looked at it strictly from that here are the environmental side of the world that it concluded for Colorado that this emission factor was appropriate. That's how I read it. That is basically the extent of it. Dissecting it more in terms of deciphering between the accuracy of those studies, including that one, that is not a level that I personally got into.
Okay. In terms of the overall, there was a lot of discussion about volume of air and some discussion about emissions for that. When you're sizing the system, you basically assumed an accumulator when it would be appropriate. Is that correct?
Yeah, and well, the costs of that we developed, if you recall the picture in the PowerPoint, there is an accumulator in that skidded system. So the costs were all encompassing for the purpose of those, 5 and 15 horsepower estimates.
But you were trying to account for the fact that often operators will use the accumulator in order to avoid having to put in a much bigger compressor.
Yeah, it's not.
Contain the air.
Yes. And, if that, usually you see these accumulators for all systems, regardless if the compressor is a, reciprocating type or, kind of a continuous VFD type of compressor, you'll see that. But as far as I'm concerned, the cost was incorporated in that the skidded package.
Yeah, thank you. And then you talked about some of the additional safety factors and air demand that you had to address. Part of that design is you have to assume that some valve may stick at some point in time, and you need to account for that possible loss against your instrument air system. Is that correct?
Yes, that's correct. We have to try to predict again the any malfunction and try to size it so the rest of the facility doesn't go down off that one thing.
Thank you very much. That's my last question.
Okay, thank you, Mr. Heiser. Thank you very much, Mr. Meyer, for your testimony. And
Thank you.
like we can excuse you for the moment. We do need a break. Let's come back at 10 of 3, please.